Hello dear students. From this video onwards, we are starting a new topic, Turing Machine. Well, in the earlier videos, we were learning about context-free grammars and push-down automata. Now we come to the most powerful machine called Turing Machine. Before we write definition of Turing Machine, it will be nice to see block diagram of a Turing machine. Check that the block diagram of a Turing machine has a tape. This is called as input tape. Why? Because the input string that we are going to process is coded or is stored on this tape. So our Turing machine is going to read the input from this tape. Now you see, this tape, theoretically is infinite tape, infinite length tape. That means on both sides, on this left side and on this right side, at both sides, this tape is of infinite length. You will not agree this, I know, because practically or in real life, it is not possible to have a tape of infinite length. But theoretically, initially, we say that the tape given to the Turing machine or the Turing machine uses input tape which is of infinite length. Now you just check the input symbols which are actually stored on this tape are surrounded by some special symbol called blank symbol. So you can imagine that before this input, that means before the input starts, and after the input, that means where the input ends, there is infinite number of blanks. This infinite blanks are there. Okay. Now these blanks are denoted by us in our example by capital B. But that's not a convention. You will see every author uses his or her way of showing blank symbol. So this is the first component of the Turing machine. It has input tape of infinite length. Then the another component of Turing machine is this head. Obviously you need an electronic head to read something from magnetic tape. Now this head is actually a read write head. There you are. Very important point. You recall that PDA also had a tape, a input tape obviously, because it should read input from the tape, and PDA also had a head, but it was read head. You can only read symbols from the tape. You cannot write something on the tape. But you observe this particular head given is both meant for reading and meant for writing. What it means is at any point of time, Turing machine can write something on the tape. By write, what I mean is it can even overwrite some input. For example, the input originally was A, and Turing machine makes a decision that it will overwrite this with capital X, or Turing machine can go to this particular location here and write something like Y. So at any point of the tape, Turing machine can write some new symbols or it can read symbols. But don't forget, like any other machine, this Turing machine can also read only one symbol at a time, or it can write only one symbol at a time. So in one go or in one step, we can't write 4 or 5 symbols. At any step, it can write only one symbol and it can read only one symbol. Further, Turing machine is having finite state control. Recall, any machine has states like Q0, Q1, Q2, and so on. Like PDA had initial state Q0 or DFA had initial state Q0. Then we had transitions to other states, and some of the states were final states. So Turing machine is also not different. It will also have finite states which will be controlling the overall working of the machine. So as such, block diagram of the Turing machine looks very simple. But what is magnificent about Turing machine is that it can read or it can write on the tape. Now, one more thing, the last thing, but not the least, very important point is this head, which is read or write head, can be moved in any direction. That means, suppose we want to move this read write head one place to the left, or maybe we want to move this head three places to the right without actually disturbing any of the input symbols. We can. How is this so important? Recall in push down automata that we just now saw in the past, you know, this was only read head first of all. Head given was only read head, we can't write. And it can go only to the right. This head can be moved only to the right. That means it was a sequential tape given. The tape is sequential, meaning that you can run the tape only in one direction. But the tape given over here is a random tape. Please try to understand. This is nothing but a memory, because memory is nothing but something which can store. But this memory is random because you can move in the memory. Moving in the tape is moving in the memory either forward or backward. That means you have control in the Turing machine to move this head to the left or to the right. That's magnificent about Turing machine. And this feature makes Turing machine most powerful machine. Okay, so fundamentals of block diagram I have explained in this video. Now the definition of Turing machine, yeah, this is not the definition, this is just how Turing machine looks like. Definition of the Turing machine will be seen in the next video. Thank you very much.